Hi, I'm Phil, and today we're going to look at timers and clocks and managing your time with microbit. I'll do this in two parts. The first part will be the introduction, and we'll talk about clocks. And the second part will look at timers. So let's move on. I'm going to use a mind map to outline this workshop, and we'll start off with the objectives, the schedule. We'll look at the components we're using and the two projects, one series on clocks and the other series on timers. We'll do a review, and I'll give you some references so you can follow up. So we're going to learn about time management and also coding with microbit, so we could make a clock and we could make a timer. And that timer is going to be based on the popular commercial time timer, and we'll discover what it is and how it's different from other timers and how you can use it. And we'll make our own clock and timer. And we'll explore the microbit and learn a bit about the microbit. So the goals for coding, we'll learn how to use numbers and logic. We'll use maths, and we'll be using the microbit LED array, both with numbers and also addressing the individual pixels and using the unplot statement to do that. And we can change the timing parameters with microbit's buttons, A and B, and that leads us to event programming. And we'll be using an extension called a software real-time clock. So where do you use timers in your life? Have you got a clock or a timer at home? Have you got a timer in the kitchen? No doubt at school you're using timers. And certainly when you go to the traffic lights, you'll notice that there's a timer there. And if you've had an X-ray, for example, there'll be a timer on the X-ray machine to make sure you don't get too much radiation. So in my career, I've been looking at timers in X-ray machines, testing those to make sure that the timer works, and not only for diagnosis, but also for radiation treatment. And again, to make sure we don't get too much high energy radiation. And I've been also using timers on road signs and passenger signs. So you might have noticed signs like this on the freeway, and they're used for road safety. And also at your school, you would have a sign like this. And I was responsible for supplying those to all the schools in New South Wales. And also these signs to help motorists be more comfortable about how long it will take to finish their journey. And on traffic lights, I used timers to make sure we get the correct timing for each of the phases. So what about time management? Well, it's actually connected to a bigger goal, doing something that you want to achieve in life, and you need to break that down into a number of smaller goals, like passing an exam, and learning how you can achieve that. So one way to do it is to build a schedule with tasks and put a time limit on each of the tasks. So schedules, you might have used a schedule with some of these symbols before. And here's an example of a very simple schedule for my son, Jason, who in the morning is going to put on his clothes. So he's got 3 tasks to do, and they're all in sequence. Put on the clothes, have breakfast, and do some work. And to remind him what the current task is, we put that into a box that Jason is doing this now. So that's the morning. And in the afternoon, he's got a different series of tasks on his schedule. So he's going to do exercise, go to the garden, have dinner. And again, we can see what he's doing at this current moment. And at night, he'll have a shower and he'll go to sleep. So after school, you might be having a snack, play, exercise, do your homework, have dinner, watch TV, have a shower, brush your teeth, put on your pajamas, then it's bedtime. So here's an example of a schedule. And you might like to put it down with times. So the same schedule with a duration for each of the activities. And we're going to spend time looking at how we can time those activities. And we'll start off with a workshop. So we're looking at these various tasks. And overall, we're going to do an introduction, learn about the microbit and Makecode. We'll be looking at 3 projects, a simple clock, an accurate clock. Then after the break, we'll do the timer. And for the components, we'll be using microbit version 2. But also version 1 will be okay for the 3 projects. We'll also learn about real-time clocks and how you can actually put the microbit onto a strap and wear it on your wrist. So let's have a look at the microbit. So have you used one of these before? What we have is a microbit, and on one side we've got the 2 buttons. Button on the left is button A, then there's button B on the other side, and in the middle there's the LED array. And we connect the microbit with a USB connection is right on the top. And we've got plenty of memory for the projects that we're doing today. And we can also learn more about other resources on the microbit, like radio. And it's got a speaker and a microphone. And we'll be using the speaker to give us alarms for our clock and our timer. Makecode is the software which works on Chrome, and this is where you develop your projects. And this is what it looks like. So you might like to go to your Chrome browser now, type in chrome.microbit, and you should get a screen that looks similar to this. And what we have is a menu bar, and that's followed by the simulator, the toolbox. Then we've got the program area, or the canvas where you construct your programs. And we've got the menu, the tool bar. Okay, so there's A for our menu, B is our simulator, C is where our toolbox is, D is the canvas, and E is where we download our programs to our microbit. And the projects we'll be working on are clocks, and there's 2 types. We've got digital and analog. And on the demonstration, we'll have examples of both of those. And for our timers, we'll be looking at timer and emulating that using microbit's LED arrays. Okay, so let's start with project 1. It'll be a very simple clock. The starting time will be 4 p.m. and we'll show the time on microbit's LED array. And actually we'll scroll that time across with hours, then a colon, followed by minutes. But you can also adjust the time, but we'll only adjust the minutes. So if you press button A, you can increase the minutes, or if you press button B, you'll decrease the minutes. And these are the requirements of our project. So here's the project. So all you've got to do is copy this onto your Makecode screen and then download it onto your microbit and check out that it works. So let's go through the project step by step. And on start, we create 3 variables, the hours, the minutes, and the seconds. And we're setting the time to 1600 hours or 4 p.m. in the afternoon. In the forever, this is where most of the work occurs. And we spend most of our time just pausing for 1 second or 1000 milliseconds. And we then increment the seconds after waiting for 1 second. And if it reaches 60, we reset it back to 0 and we increase the minutes. And if the minutes gets to 60, we then reset the minutes and increase the hours. And after we've done that, that's like a small algorithm that processes the time for us. We show the hours and we show the number for our minutes. So again, here's where we process the seconds and process the minutes and the hours. And we're ready to download. And you can do this in 2 ways. One is you can download using the middle. Right on the bottom, you've got a choice of download on the right. And in the middle, we've got the name of our program. And there's a small icon there of a disk drive. And you can press that. Or alternatively, if you've paired your microbit with Chrome, you can use the alternative download. Okay, so how did it go for our basic watch? So you've already constructed it. You've downloaded it. And you need to do some testing. Okay, so how can you improve it? And where are the weaknesses in this project? Well, let's see if we can overcome some of those weaknesses now. And we're going to use a software real-time clock. And the microbit, the microprocessor there, has another unit called a timer. And it's working all the time, even when our CPU and other resources are working. So this program, the objectives here are to use the microbit clock and display that on the LED, similar to what you did before, and similar way of incrementing or decreasing the minutes. And overall, we haven't actually added much more because we're using a software real-time clock. And how accurate is this one compared to the previous one? Okay, so here's the project. So I'll get you to copy this onto your Makecode browser and download it and see if it works. Not much to it on this one. On the startup, we name the project. So there's my project name. And I'm using the extensions for software real-time clock. And I'm setting the time to 4 o'clock in the afternoon. In the forever, I just grab the hours, put a colon between the hours and the minutes, and I show that on the microbit LED array. And when I press button A, I'm using a bit of maths to increase the minutes by 1, or if I press button B, I decrease it by 1. And to do this, we go to the extensions and select software real-time clock. And we have another set of tools or statements that we can use in our program. And we're going to use these ones. This is where we get the set time. And we also scroll down and we can then grab the envelope and we can then access the hours, minutes, and seconds. And here's our project. This is what it looks like. So similar to what I showed you before, but we've added a colon between the hours and the minutes. Okay, so here's a challenge. Once you've got that going and you've verified that it works, how about you make a clock which is accurate and shows the hours with a colon and the minutes all on the tiny microbit LED array. And what we're going to do is use binary numbers, but we're going to code them as binary coded decimal numbers. So we get each of the rows, and the hours has two columns, and each of those are decimal numbers, but we'll convert those into binary numbers separately. So we've got hours and we've got minutes. Minutes are the same. We're going to use two columns for our minutes, and in the middle we'll have our colon. Okay, so see if you can do that, and the results will be on my YouTube channel. Okay, so this is what the demo looks like. And if you actually look at the two photos, the one on the left shows the clock, which I'm wearing, and it doesn't have the colon. The other one's got the colon. And the time that we're showing at the moment is 1 hour and 2 minutes. So there's our clock, and there's what the program looks like. So I'll leave it up to you to go through it and download it and see if it works. And for the next YouTube video, we'll look at timers, and these will be based on the time timer, and that'll be it for the time being. So bye for now. So here we have the microbit, and it's got a hat on it, a kittenbot cover, and it's using the bitware for our clock. And it's got batteries, so there are a couple of batteries there. And to start the clock, what we'll do is just turn on the power. We're conserving power at the moment, and you should be able to see the announcement. It'll tell us the program, and it's a binary clock. So in the middle, it's flashing the seconds, and on the right, we've got the hours. So this is showing time in a binary format with BCD, binary coded decimal. So on the right, we've got hours, and on the left, we've got minutes. So there are two columns for both hours and minutes. And at the moment, it's showing a time of 1 hour and 2 minutes.